For lesson 2 on ratios, we'll be talking about equivalent ratios. So a ratio is a multiplicative comparison of two quantities, meaning two numbers, which describe the same attribute, which just means the same thing. So basically, you have two numbers that you're comparing, and they're describing something that's related, okay? And we say it's multiplicative because it's like a fraction, where when we simplify, for example, like up here, 2 fourths, 2 to 4, when we simplify, we're using division or multiplication, right? So like we could take 1/2 and do this to it. So it's multiplicative. It's not dealing with like adding or subtracting. It's dealing with multiplying and dividing is the whole point of that. All right. So we have some options. We can do dogs to animals using the word to. We can compare students to teachers using our symbol here, our ratio symbol. Or we can write it as a fraction, red marbles to blue marbles. Okay. Ratios that are equivalent can be simplified to the same value. So just like we can compare fractions by simplifying them, we can compare ratios by writing them as fractions and then simplifying them. So for example, 4/5 is the same as 8/10 because you multiplied by 2. And it's also the same as 12/15 because if you multiply 4/5 by 3 and by 3, you're going to get 12/15. Okay? Same deal here, 1/6 times it by 2, it turns into 2/12. 1/6 times it by 3s, and you're going to get 3/18. Okay? All right, so for these, let's create a couple of equivalent ratios. So I'm going to start by making them look like fractions. So 7/11. And I'm just going to pick a number. I'm going to try 2, just to keep it easy. So 2 on the top, on the bottom. As long as you do the same thing on the top and on the bottom, it's totally fine. So I got 14/22. All right, the other one I'm going to do is, let's see, how about we just do times 3 because that's another small one. So I'll do 7/11 times 3 times 3. As long as you do the same thing on the top that you do on the bottom, it's perfectly fine, okay? All right, now we've got 18/12. And actually, I think we could simplify that. So we could go the other direction and use division. So I could try like 2. 18 divided by 2 is 9. 12 divided by 2 is 6. So there's one equivalent ratio. And then we could try multiplying by 2 instead. So 18/12 times 2 times 2. That's going to give us 36/24. And so that's another equivalent ratio. Okay? All right, now another thing you might need to do is decide if two ratios are actually equivalent or not. So we can actually do that by just following the rules of our fractions. So 2/5 and 8/20, I have to decide, can I turn 2/5 into 8/20? Well, if I want a 2 to turn into an 8, I would multiply by 4. And I have to do the same thing on the bottom if it's going to be equal or equivalent. And that worked out. So you can say yes, and we multiplied by 4, or we scaled up by 4. Okay? Now, for the next one, 12/4 and 6/3, I can't really tell just by looking at those, but actually, I can look a little bit more closely. Turning a 4 into a 3 would be kind of hard, but 12 becomes 6 very easily if we do divided by 2. So do the same thing on the bottom because that's the rule if you want them to be equal. So 12 divided by 2 is 6, but 4 divided by 2 isn't 3. So these are not equivalent. Okay? And for number 6 here, 8/6 and 20/15. I can't make a 6 turn into a 15, and I can't make an 8 turn into a 20. So what I'm going to do instead is our other method where we're going to simplify them to see if they turn into the same value. And if they do, then they're equal. So 8/6, I can divide it by 2 and 2. That's going to be 4 thirds. Okay, now if I do the same thing to the 20/15ths, let's see. Those would both be divisible by 5. 20 divided by 5 is 4. 15 divided by 5 is 4/3. When you simplify, if they come out the same, then they are equivalent ratios. And that is what happened here. So we can say, yes, they simplify to the same thing, to the same value. For our last few examples here, we can use a method called proportions to solve for unknown numbers in our ratio problems. Audrey and Megan are decorating for a birthday party. Audrey hangs 4 streamers in the same amount of time that Megan hangs 6. So right there is my ratio. So my ratio that compares Audrey to Megan is going to be 4 to 6. If Audrey hangs 12 streamers, then how many will Megan hang? So we don't know how many Megan's going to hang, all right? So we could say, okay, if instead of 4, Audrey's number turned into 12, what would that mean that Megan's number was going to be? Now, if you want to be a little bit more sophisticated about this, you can use what's called a variable, which is just a letter that stands for something. For example, M for Megan. If that's confusing, you're welcome to use a question mark until we talk about this lesson with the variables a little later on. But I'm going to use an M. All right, so 4/6 equals 12 over something. And we can solve this just by using equivalent fractions. To turn a 4 into a 12, that would be times 3. I have to do the same thing to the bottom if I want it to stay equivalent. So that means that this number is supposed to be 18. So Megan hangs 18. We just used equivalent fractions with our proportion. Okay, let's try another one. So in the computer lab, there's 1 PC for every 3 Mac computers. That right there is our ratio, 1 to 3. It's PC to Mac. If the computer lab has a total of 24 computers, then how many are Mac? Now, I did catch that word total. Neither of these are a total. 1 and 3 are just part of the number of computers that we have. If we want the total, we have to add. So the total actually would be 4. 1 plus 3 is 4. But in real life, we don't only have 4 computers. It says right in the problem we have 24 computers. So in real life, we need 24 as our total, okay? So we got to somehow turn a 4 into a 24. And whatever we do to that, we're going to do the same thing in our ratio as well, okay? So to get a 4 to turn into a 24 with multiplying, I can use 6, which means I got to use 6 up here as well. So 1 times 6, that's going to be 6. 3 times 6, that's going to be 18. 4 times 6 was 24. It worked. The question asked about the number of Macs, and I can see that answer right here, just right in this line. There's going to be 18 of them in real life. Funny, we got the same answer for both questions. Okay, number 9. On his math facts quiz, Jeremy missed 2 out of 11 questions. Out of is another one of those things that tells us we have a ratio. So 2 out of 11, okay? And this top number is how many he missed, and then the 11 is the total number of questions. The next quiz has 55 questions. How many can he expect to get correct? Okay, we have to change this. If he missed 2 out of 11, that would mean that he got correct the other 9 out of 11. Okay, so we're going to use 9 out of 11. Now, the real quiz that he's going to take next doesn't have only 11 questions. It has 55. So let's create our equal ratio. If we want them to be equal, 11 times 5 would give me 55. Do the same thing to the top to keep it equal, and you'll get 45. So he can expect to get 45 correct. If you had done it with the 2 over 11, you would have gotten how many he would miss, and you'd have to subtract to get your answer, which is fine. For number 10, a lemonade mix calls for 2 tablespoons of mix for every 3 cups of water. There's our ratio. So mix is going to be 2, and water is going to be 3. If the container has 24 tablespoons of mix, then how many cups of water will be needed? So in real life, we don't have just 2 tablespoons. We need it to turn into 24 tablespoons. And to get that, we just have to multiply the first fraction, the ratio, by 12. 2 times 12 gave me 24. We have to keep it equal, so do the same thing on the bottom, and you'll get 36. So to answer the question, 36 cups of water. So you literally just copy the label for the bottom of the ratio. Last one. Jamal says that 18 to 12 and 3 to 4 are not equivalent ratios. Margie says they are equivalent ratios. Who is correct? Justify your solution. My first step here is just to write them as fractions because I think that's going to show me a lot more quickly if they're equal. And what I'm going to do is just simplify both of them and see if they're the same. So 18 twelfths. I know I could use 2, but I actually also know that 6 would go into both of these. So I'm going to try dividing both by 6. So I get 18 divided by 6, which is 3. 12 divided by 6, which is 2. So if I look at these, I got 3 over 2, and then 3 over 4 is actually already simplified. So would you say that they're equivalent? No. Another way you could do this if you don't like that method, you could take 3/4 and try to see if it's equal to 18 twelfths, like this. I can turn a 4 into a 12 by doing times 3, but on the top, I have to use 6 to get 18. So this one doesn't work. So they're not equivalent. So Margie is correct. No, never mind. Jamal is correct. And there we go.